Good morning, Algebra 1 students. Today we're going to be looking at Lesson 93 together. But before we do that, let's just, there's a few notes that I need you to pay attention to. You guys have a packet that is due today for lessons, I forget which letter packet it is, but I know it covers the lessons 85 through 88. So if you'll please make sure that you turn those in, you can give those to Mrs. Fort, or I will be in today, so you can give them to me. But I'll be in this afternoon, so if you're planning to leave before then, you will need to be sure to get the packets to Mrs. Fort so that I can have those turned in today. You'll have this turned in today. Also, if you have me for yearbook, when that time comes, I'm not going to have you guys working on yearbook today. Since the yearbook has been submitted for production and printing, I need to pull out some lessons and so forth. So you're going to be working on your math today. So you can, if you finish today's math, you can move on to the next lesson and just do the problems that show from previous lessons, and that way you can maybe get a little bit ahead. Also, so you're going to be working on math. Also, what else did I want to tell you? There was something. Oh, the review sheet. Mrs. Fort handed you a review sheet number 22. I am going to cancel that test. You were scheduled to have a test this Thursday, but since I'm not there today, I'm not going to give you that test. And we'll talk about a new testing schedule when I get back. Okay, so you can just put the review sheets, you can give them back to Mrs. Fort, or you can hold on to them and give them to me in class on Thursday. I don't think you're going to need those. Okay, so let's go ahead and get on with the lesson here. The title of the lesson today is Products and Quotients of Rational Expressions. This is probably one of my most favorite things to do in algebra. First of all, let me go back up here to this little blank sheet of paper. We know that we can multiply any fraction. It can have all kinds of funky stuff going on. If you had a fraction that looked like this, you guys know that what you would do is you just can multiply across, right? So you'd have 12x squared a over 5y. Okay, likewise, if we were to divide this, let's say it looks like this, and it's a division problem, what happens now? Remember, anytime that you divide by fractions, and in fact, look down here on your packet, anytime you divide fractions, what happens? We do the KFC method, right? Keep, flip, change, where we keep our 3/4, keep the first fraction, flip the second fraction, and change the sign. Well, the same would be true of something like this. So you would actually rewrite this way. And this is nice because now you have things you can cancel out while you're simplifying, and you're going to end up with 4y over 15a. Okay, that's just multiplying and dividing fractions. So today we're going to look at longer, more complex fractions, but I think you're going to really like them. Let me add a page here. For right now, I want you just to watch a couple of examples, and then we're going to build one in your notes so you'll have it. Let's say you have a fraction that looks like this, x squared minus 25. And you recognize that as the difference between two squares right there. And this is a multiplication problem with two rational expressions. And when I look at these, now this is where you're going to get to take all your skills that you've been learning about factoring so that you can simplify this big thing down to almost nothing. So we're going to put this into play. So let's look at the very first top part of our fraction to the left here. That's the difference between two squares, right? So we know this is going to be x plus 5 if I factor this times x minus 5. What about the bottom over here? Let's look at this one now. X squared minus 7x. Looks like they both share an x in common, so I'm going to factor that out and put back in parentheses what would remain, right? Because if I were to multiply this, I'd have x squared plus 7x, which is what we started with over here. All right, that takes care of this one. Now let's look at this one over here. So the top part of this, the numerator of this fraction to the right, allows us to factor out another x here. And let's look at the bottom. We can factor that into binomials. You know we're going to have an x and an x. Okay, so let's think of this. What is it, if you're still using this method, remember you're trying to figure out what two factors would multiply to give me a negative 15, but when I add those together, I get a negative 2. Right, so we have the product, and we have the sum, and we have factors over here. So the product has to be negative 15. The sum is negative 2. So what do I multiply to get negative 15? Well, I could have negative 3 times a positive 5, but if I add those, will I get a negative 2? No. What if I flip the signs? What if I have positive 3 and a negative 5? Well, that gives me negative 15. And when I add those, does that give me the negative 2 that I'm looking for? Yes, it does. So here's the factors I want to use. So I'm going to have x plus 3 and x minus 5. I'm going to erase this to get this out of the way. All right, let's keep going. Now, before I write out my answer, now this is a multiplication problem. We can cancel, we can cross cancel, we can simplify by canceling within the same fraction as long as you're canceling factors, which all of these are factors, so it works out really perfectly for us. I'm going to change the color of my pen and we're going to go to town on this. So I have x plus 3 and I have x plus 3. I have x minus 5 and I have x minus 5. I have an x here. Whoops, woo, come on back up here. And I have an x here. And what do I have left? The only thing left is x plus 5 and x plus 7. So that is fully simplified, and this is your answer. Okay, now let's look at another one. Let's look at, this one's just going to be a little bit lengthier, but it's really the same kind of a problem. Let's see if you can work this through with me. And if you want to write this in your notes, you can. You have space at the bottom to do this. And x squared minus x minus 2. All right, let's look at the first part of our fraction up here. Can I factor this into binomials? Yes, I can. What is it going to be? What can I multiply together to give me negative 6? And when I add them, I'm going to get a positive 1, right? The coefficient of that x is 1. So whatever factors I pick for negative 6 have to add together to give me positive 1. So I'm assuming it's going to be 2 and 3 somehow. So let's see. If I need a negative and a positive sign here. When I add them, they have to be positive 1. So that means my 3 has to be positive. Now let's look at the denominator here. Well, let's factor this into binomials. We'll put an x and an x. What are my factors of negative 21? Well, the only ones I know of are 7 and 3, right? Other than 21 and 1. But 7 and 3 will work. How do I multiply those? Where am I going to put my signs? I know they have to multiply to get negative 21. So one has to be negative and one has to be positive. How do I decide? Well, when I add them, they have to give me this negative 4. So how would I do that? That means my 7 needs to be negative and my 3 can be positive. All right, let's factor out the rest of this thing. So I have x and x at the top here. And I have 7 and 1. And I have, I think, right? Yep, has to be 7 and 1. And a negative and a negative. Because a negative 7 times the negative 1 is positive 7, right? That gives me my positive 7. And if I add those together, negative 7 and negative 1, I will get negative 8. So I've successfully factored that. Let's do the same thing for the bottom here. Looks like it's going to be 2 and 1. Has to be one's a negative, one's a positive. And that right there will work. All right, let's go to town by canceling some things out here. Let's grab a purple pen now. Okay, I have an x minus 2 and an x minus 2, an x plus 3 and an x plus 3, x minus 7 and an x minus 7. Look how wonderful that is. I got rid of the entire first fraction. The only thing that's left is this right here, and that's going to be your answer, x minus 1 over x plus 1. All right, you've got one now. We're going to look at dividing fractions. Now this one is actually in your notes, so let's go to your notes right here. And we're going to work this one out. I'm going to go ahead and keep my purple pen going. Okay, so this is division. Whew, excuse me. This is division, right? So what are we going to do here? We're going to use the Kentucky Fried Chicken method, right? Keep, flip, change, KFC. Alrighty, let's go ahead and figure this out. So let's look at the numerator on the first fraction over here. X squared minus 2x. They both share an x in common, so let's factor that x out. We'll put back in here x minus 2. What about the denominator? This looks like a polynomial here that we can factor into binomials. Bi meaning 2, so I can factor these into 2 factors. Let's do 4 and 2. See if that'll work. Has to multiply to give me negative 8, which means one has to be negative and one has to be positive. But when I add them, they have to give me that positive 2. So 4 is going to have to be positive, 2 is going to be negative. Okay, now we're going to flip this thing because KFC says that's what we do. Now, I don't want to do too much, but if I flip that, this is going to come to the bottom and this is going to go to the top. So let's deal with moving this top part down to the bottom, and we're going to go ahead and factor out that x. And on the bottom part, as it goes upstairs, let's go ahead and factor it. This will just save us from having to rewrite it again. Alrighty, x and x, probably a 3 and a 4, and a positive will do. All right, so let's see what we can get rid of. We have 2 x's we can get rid of. Do we have an x minus 2? Yep. X plus 4? Yep. So all that's left is x plus 3 over x plus 5, and that's your final answer to that one. Okay, that being said, we're all done. We're going to go down to our practice problems, and if you'll turn to your book on page 389, you're going to see these problems there. Let's go ahead and write the first one in. The first one is, let me write this, make this a little bigger. X squared minus x minus 6. X squared minus 6x minus 16 divided by x squared minus 3x over x squared minus 3x minus 40. All right, so take note, guys, division. So what am I going to have to do here? KFC, right? Keep, flip, change. Let's go ahead and factor the first fraction over here with these 2 expressions. We have x squared minus x minus 6, and we have x squared minus 6x minus 16. Let's focus on the top one here. X and x. What are my factors of negative 6? I could have negative 2 times 3, negative 6 times 1, or I could change the signs around. Oh, excuse me, but remember, sorry, it happens when I video record late at night. This is a coefficient of 1 in here, isn't it? So whenever I do pick, it has to add together to give me negative 1. So let's choose to use 2 and 3. Which one's going to be positive and which one's going to be negative? Well, if I add them, they have to give me that negative 1. That means negative 3 has to be the negative 1, or 3 has to be the negative 1. 2 can be the positive 1. On the bottom here, what are factors of negative 16 that when they add together will give me negative 6? I'm thinking of perhaps 2 and 8, plus 2 and minus 8. This would give me negative 16 when I multiply them. And if I add them, it gives me negative 6, which is perfect. Okay, now we're going to flip this thing right here. And as I'm bringing this down, I'm going to go ahead and factor the x out. And as I'm taking this back up here, I'm going to go ahead and create my factors here as well. So we have x and x. Product, negative 40. We need some factors of negative 40. Let's do 8 and 5. Because when I add those together, if I have a negative 8 and a plus 5, I'm going to get negative 3. And that gives me the coefficient of x in there. So we're good to go. All right, let's start going to town and canceling these things. We have x minus 3s. We have x plus 2s. We have x minus 8s. Wow, I thought I was going to have... Nope, I guess that's it. Okay, so the answer then is going to be x plus 5 over x. And that's the answer to letter A. All right, let's move on to B. Letter B. See, these are kind of fun, really. I'll use green for a change. All right, so we have this x squared plus 12x plus 36 over x squared plus 13x plus 42. And this is a multiplication problem, so no keep flipping and changing. We just leave it as it is. We just need to factor and simplify by canceling any terms that we can cancel. All right, here we go. First things first. What are the factors of x squared plus 12x plus 36? Well, I'm thinking perhaps 6 and 6, because I know if I multiply those together, I get 36, but if I add them, I get that positive 12. What's the bottom here going to be? X squared plus 13x plus 42. All right, so I know that 6 and 7 are factors of 42. Is there any way in my mind I can think of adding those together to get me 13? Yes, exactly that. So 6 times 7, if I multiply those positive numbers, I'll get positive 42. When I add them together, I get positive 13. If you want to pause the video right here and see if you can finish this out, please by all means do it. I'm going to keep talking for those of you that are staying with me, or when you come back to check it, you might need to hear me talking a little bit. All right, numerator, x and x. What am I going to need here? 7 and 3, plus and minus, right? If I multiply those, I'm going to get that negative 21 right here. And when I add those, I'm going to get this positive 4. And that's the ticket, okay? Let's look at the bottom. Oh, goodness, excuse me. All right, what factors do I have for negative 24? That when I add this together, I can get a positive 2. Well, I'm thinking of 6 and 4. And to make it a negative 24, when I multiply them, one of those has to be negative and one has to be positive. But before I can assign those signs, I have to go to the coefficient of x and see what it needs. Those need to add together to be. It needs to be a positive 2. That means I can do x plus 6 and x minus 4. All right, let's go to town and cancel. We have x plus 6 is here, x plus 6 is here, x plus 7, and all that's left is this x minus 3 over x minus 4. That's the answer to letter B. Okay, guys, have a great time working out those problems. Please remember, if you finish early, you're not to just sit still in your book. You're not to be chitting the chat. You need to go ahead and work on your math. Just go ahead and either give those review sheets back to Mrs. Fort or just poke them in your folder. I'll get them from you on Thursday. Hope you guys have a great day. Remember to turn in your packet that I brought to your attention at the beginning of class. Let's see what I wrote down. 85 through 88. Those are due today. You can either hand those to Mrs. Fort or when you see me around this afternoon, you can give them to me then. All right, guys, have a wonderful day.